basically my agenda is I don't want to dedicate only with respect to of the Spring Boot or only with respect of the Angular. First, we will touch the core concept of the Kafka. So because once you understand what's the purpose of the Kafka, what is the necessity of the Kafka, these all are the wrappers here. Let us say if you are having the plain Java also without any framework, leave about the Spring Boot. If you are having the plain Java also, you can work with the Kafka. If you are having the .NET, you can work with the Kafka. If you are having the Node.js or Python, that doesn't matter. So these all you can just consider. So these all are the wrappers to interact with your Kafka. And UI side, that's your choice, maybe Angular, React, or Vue. So that your choice, you can go with the plain JavaScript also. So that doesn't matter. So first of all, put aside of this technology. That may be a Spring Boot, that may be a .NET, that may be a Angular. We don't worry about this. First, let us encounter the actual point. What is the purpose of the Kafka? And then we will see how we are going to be integrating this Kafka. So actually, this bootcamp was designed with the two parts here. So part one, part two, in the account of the time, because earlier we used to conduct the almost 3 to 4 hours of segment, but we understand 4 hours conducting it's a little bit energy drain also. So I don't want to drain that much energy. So we'll do one thing. So part one, part two, I just split it. So in the part one segment, we'll see Kafka and how you are going to be performing the operations with the Kafka and the Spring Boot. So then we are going to be seeing the integration with the UI. So the major agenda of today is, I mean, the bootcamp focused on working with an end-to-end application, completely UI or backend with your streaming mechanism or the Kafka end-to-end interaction. So that's for today's agenda. So if anyone having any kind of other expectation, I'm just setting the limitations for that. So the main focus on the UI wise, I'm taking care about Angular. That your choice. If you are not comfort with the Angular, you can convert with the React application also. Backend, I'm taking the Spring Boot. Suppose you guys having the background of the Python or something called as a .NET. So that's you are going to be seeing that one. And similarly, we are going to be stepping a deep dive, most focus on the Kafka side we are going to be doing. Why? Because generally Kafka means everyone will talk about Kafka. Okay, it is something kind of a distributed message broker. First of all, why this distributed message broker came into the picture? So before Kafka also a lot of things are there. But why Kafka gained this much market? So why Kafka is more and more reliable, and why Kafka is a major, it plays a major role that to especially microservice architecture, it will place a major role. So where this Kafka got the market, so that's we will see. So that's where you can able to work with any technology. That doesn't matter. So once you know the concept, simple dear, whatever it may be, if you take any programming language, any technology, what you need to know, the syntax you need to know. Let us say you are working with the Java, same if loops, same kind of a stuff only. .NET, the same kind of if else loops like that only. Python, the same kind of if else loop, all things only. But the thing is, you need to know the syntax. The syntax is nothing but the core concept of your base language. Similarly, here also, that may be integrating with any framework, we don't bother. That may be a Spring Boot, that may be a .NET, that may be a Python, that may be Node.js. That doesn't matter. I don't care about that also. But if I know the core concept of the Kafka, so then I can see the usage with the frameworks like a Spring Boot, all those things. So that's we will see today. Is anyone have you ever heard about something called as a Kafka? Generally in a day-to-day or somewhere, have you ever heard about the
Yes,
Kafka or
yes,
any
it is a message broker,
idea? Okay,
distributed message
exactly.
broker.
Distributed message broker. Okay.
Which
Any other thoughts?
It avoids direct communication between
Okay.
services and it will make this stable.
communication
Used
between
used for
producer and consumer.
used for asynchronous communication, which doesn't need response.
Okay. All your points valid, but I'm trying to highlighting the 2 points. Someone told, so this is a message broker. So first of all, what is a message broker? That is the actual starting point we need to work out, because Kafka is built for the sake of the message broker, but those advantages got elevated. that is actually introduced as a message broker, but the usage of the Kafka is more and more that is actually not only using the message broker, sometimes it is using something called the fault tolerant application mechanism also it is going to be using. So that is the one point I want to highlight. Second point is someone told, so it doesn't wait for the response, all those things. So that's point I want to highlight. So let us say, just let us take a practical example. So first of all, what is the message broker before doing all those things? So let us just take a simple example. So let us say I have a service one. Consider this is a microservice or an application that your choice. There is a distributed application. So you are going to be working with some kind of SOAP or REST, that doesn't matter, a distributed application. So you are going to be communicating with another service. Probably you guys are familiar with the Spring Boot. So let us work with consider these two are the two Spring Boot microservices, microservice one, microservice two. So I'm considering this is something called as a order service. Let us say this is something called as a payment service. Two things I'm having. So I'm having the order service and I'm having the payment service. Two things I'm having. So now order service want to communicate with the payment service. Generally, what is the initial idea you will get? Suppose if I want to communicate with the one microservice to another microservice, so what is the working mechanism you will pick up? How you can communicate between a microservice to microservice? Suppose if anyone having a Spring Boot knowledge.
REST template.
Exactly. I will go for the REST template.
REST
So
template, fin client and web client.
Web client.
Fin client.
so these all are
Kafka.
example of your REST template only. So you can consider, let us say we are going for the REST template. Suppose if you are using something called as a React based applications, you can go for the web client. So Vegan client is almost deprecated here. Now Vegan client is not supported, like because it's need a ribbon. So in a Spring Boot 3 onwards, a lot of changes first happen because Joule proxy itself deprecated. So there is no support for the Vegan clients. So you are in, I think you are in a still a Spring 2 era only. So Spring 3 Vegan client is not supported. So now REST template is actually introduced. REST client is another new thing that is also introduced from Spring Boot 3 onwards. But both are same. REST template, REST client, both are same. Spring Boot 3 onwards, these classes introduced. Whatever the functionality you are working with the Vegan ribbon client, those kind of load balancing, all those things that introduced in the REST client itself with the annotated load balanced annotation, you can manage that one. That is Spring Boot 3 enhancements. Spring Boot 2 also is there, but Spring Boot 2 additional choice, open client, Vegan client you are having. But those are deprecated. So we are having the REST template or REST client. If you are working with React-based applications, then you are using the web client you are going to be using. So that is come with your Reactor project. So there you can use that one. Let us say I'm using the REST template. So order service want to send a request to the payment service. You are using the REST template. You are going to be performing the operation. Everything is going to be working good, and everything is going to be making fine. Let us say, if you just compare this, the communication between happening with your order service to payment service, nothing but your REST template, happening through a protocol called as a HTTP protocol. Agree?
Yes.
So the request is going to be sending through the HTTP protocol. So that's where once you send any kind of a request, so maybe you written programmatically, you taken care about the asynchronous mechanism, React, everything. Even if you go with something called as a reactive mechanism also, once the request was initiated with the order service to payment service, as because it is using the HTTP protocol, definitely it has to wait the response. So that's the reason when you send us some kind of a request, your browser is going to be still loading, because once the request was initiated, the HTTP, that has to be acknowledged. that has to be acknowledged. That acknowledgements generally we will do with the promises here, like whether it is a success, nothing but fulfilled or rejected or pending state. That's what we're going to be calling. So definitely, once the request was initiated through a HTTP channel, that has to be acknowledged. Indeed, that is something called as a synchronous mechanism. That is not asynchronous, that is a synchronous mechanism, which means once the request was initiated from any service, if you want to initiate the second request, you have to wait until that response has to be completed, until the response has to be completed. So to overcome these challenges, Spring Boot people introduce asynchronous mechanism. You can able to raise the request parallelly, but there also a bit challenge. So once you initiate the request parallelly, all these parallel requests also wait for the response. It's not the thing. So I will raise the parallel request. So remaining request I am going to be do with my own kind of work. Means that doesn't happen. So even asynchronous programming also, let us say you asynchronously hit at the 10 times your service, 10 requests will be initiated, but ultimately those 10 requests independently waiting for the response. So when the request was initiated, definitely that will going to be wait for the response. This is a little bit a challenge. In your REST APIs. So because REST APIs use the HTTP to communicate, your HTTP is a request response protocol. It is best for synchronous mechanism. So you are going to be sending the request and you are going to be getting the response. That kind of a synchronous, it is going to be working. So to overcome this challenge, let us simple example here. I'm an e-commerce application. I want to make a PayPal payment gateway. Now, if you see, I send the request, I hold the user until my payment is going to be completed. But my payment service not working properly. And that too, I don't have a control over on that payment service because that payment service not maintained by me. That payment service maintaining by the PayPal, all those things. So that scenario, if I hold the user, hey man, wait until payment completed, you can't do any other thing. So you can't able to, at least you can't able to browse other products also in my application. So that if I do like that, I lose the customers. In the era of the distributed application, in the era of the distributed mechanism, your application should be most reliable. Let us say your payment service is not working and you don't have any control over that also. Leave that. So that will has to be performed behind the operation. But meanwhile, I want to offer some other services to the user. At least he can browse the products. At least he can add to some wish list. At least, okay, so we're going to be put that in a pending. You can able to do some kind of order. Once the payment was confirmed, then I'm going to be confirm the order. So that's message we are going to be show. So this kind of other options we need to give to the customer. This kind of a mechanism, to perform this kind of a mechanism, we are going to be using something called as a event-driven management will going to be help you. Instead of using the HTTP protocol, instead of following the request and response mechanism, I will go for the event-driven mechanism. So there what you will do is, like see, order service, payment service, the communication will happen the HTTP protocol. But the same channel, what we will do is, we're going to be convert that communication to the event-driven. We're going to be convert to the event-driven. So now just order service will raise an event. So once the event was initiated, the completion of the event, now order service don't bother. So it will just raise the event. Now payment service will going to be process that event. It will complete the event whenever it is going to be completed. So then it will going to be give the response to the order service. So to give this mechanism, we are not going to be waiting for any other service response. We are not going to be non-blocking communication. We are going to be calling as a high tolerance communication. majorly you will see this kind of a high tolerance application in a e-commerce application. So to apply this kind of a high tolerance application to serve your application in a high tolerance mechanism, we are going to be using the slightly changing the architecture to the event driven architecture. And ultimately your event driven also use the HTTP here, because communication should happen, right? Service 1, service 2, communication should happen. It will use the HTTP. But this event driven is one of the added advantage to your HTTP communication. So now through your HTTP, you will raise an event. So that event is going to be acknowledged by your payment service. To overcome this, to implement non-blocking communication between the service to service in a distributed systems, especially in a distributed systems, we are going to be using the event-driven mechanism. To manage this event-driven mechanism, we are having something called as a message brokers. We are having there. We are having the message brokers. Message brokers will going to be help you to implement your service communication in a event-driven mechanism. So you no need to wait whether the other service giving the response or not. So now you'll just raise an event. That event is going to be acknowledged by the order service. So once it was completed, so that event, target microservice will going to be give some kind of a response. Your message broker enables asynchronous communication between the services, so that your sending service no need to wait for the receiving service. So this one, sending service means order service. Your sending service no need to wait for the order service. So your message broker will actually enable the asynchronous communication with help of the event-driven mechanism. So that's where your message brokers will going to be help you. So this message broker, as a developer, you will write the code. So like, see, have you ever worked with a Spring MVC? Spring MVC?
Yes.
Yes.
So Spring, what is the main purpose of the Spring MVC, dear?
It separate the logic, it separate the code.
Without Spring MVC also, can I develop a web application?
Yes.
That's what we did, right? In the olden days, so servlets and JSP, we written all those things. But what Spring MVC is doing, so Spring MVC is giving a helping hand to develop a application with a proper MVC design. Because as a developer, you may make a mistake. So you are going to be working with the servlets and JSP. That's where unintentionally you maybe write your view logic in a servlet itself. That's where your clubbing will going to be happen. You are going to be writing all the business logic, view logic in a single thing. So that's where your Spring MVC came into the picture. It will split the logic. It will guide you. Boss, this is not the way. So all the view logic you can write in a JSP. That's where you are going to be configure the prefixes and suffixes. Controller will going to be hold on the business logic. It will return the some string that will going to be converted logical name into a physical view. So that everything was Spring MVC demand you to write, develop any web application proper MVC mechanism. Similarly, this message brokers. So this message brokers also a piece of software. Message brokers is also a piece of software that enables your application to develop in a event-driven mechanism. They will guide you. Probably as a developer, if you don't have that much knowledge how to develop this event-driven system, how I can work with this event, how to create an event, how to acknowledge the event. As a developer, I don't have a sufficient knowledge. I can develop my application event-driven without message broker also. I can write the plain code. So there you can take the, that's will call as the actors. In Java, you are having the actors. By using the actor, I can develop my own actor. I can acknowledge that actor. I can create that actor. So event-driven mechanism, as a developer, I can develop everything with a manual effort. But here, message broker will going to be involved. It will going to be give a sweet syntax. You don't need to do anything, boss. I will take care about that. So just you need to use my mechanisms. You can just to follow my instructions. You can convert your application into a event-driven mechanism. So that is nothing but your message broker. A message broker in a simple terminology here. So always don't look for the fancy definitions. No one expect the fancy definition also. So this is the major problem what you people will do. When you attend an interview also, you will always try to present with the more fancy definitions, all those things. But no one need the fancy definitions. Everyone look for the concept only. That's okay. So try to narrow down the problem. How easily you can able to explain, that will actually represent your knowledge about the subject. So simple, a message broker is a software that enables your applications or a system or a service to communicate with each other in a asynchronous mechanism via event-driven mechanism. That's it. So a message broker is a software that actually enables asynchronous communication between your system to system or service to service. Because in a distributed environment, a third party, I'm not sure, maybe that is a system, maybe that is a service, maybe that is some other. So that is nothing but an interoperability. That is nothing but your interoperability. So that's where I don't bother whether this that is a system or service or anything. So your message broker will actually enables the asynchronous communication between your service to service through your event-driven mechanism. So here I'm mentioning message broker is a software. Message broker is a software. So a lot of companies developed this message brokers here. So while the developing this message broker, lot of companies involved. So that the companies are, first company is a ActiveMQ. He is the fellow who actually developed this software. So before this, IBM is also introduced. So IBM message brokers also we are having. So but Java wise lightweight is the ActiveMQ. Then RabbitMQ. This is another company, which party is the ActiveMQ. Core is the ActiveMQ only. Then LinkedIn. LinkedIn also take a picture. Those people is nothing but your Kafka. Kafka is developed by the LinkedIn people. Now it is maintaining by the Confluent company. So it is actually, Kafka is actually developed by the LinkedIn people. So this message, I want to perform the event mechanism, asynchronous communication. So instead of I am doing all those things, these people given the framework. So that the frameworks or a framework is not the software only, simply Spring. Spring is a worker. So it's a different kind of a module. For outside people, not at all outside people think that is something called a software. Like similarly, a message is also. So
Hello?
to
Sorry,
Yeah.
your voice is breaking.
Your voice is
Just give a minute. Can you hear me now?
Yes.
yes.
Yeah.
Okay. Yeah. So that's what. So message broker is a software which enables between a service to service or system to system asynchronous communication through a event-driven mechanism. So these are all ActiveMQs, RabbitMQs, all these all are the softwares. So while implementing these message brokers, these people followed initially. So initially, LinkedIn don't have entered in the message broker market. So initially, we are having the ActiveMQ, RabbitMQ. What these people followed is, because these are the frameworks, these people followed a queue mechanism. A queue mechanism, nothing but this is the FIFO DR, first in, first out. A queue mechanism they followed, there is a FIFO. So simple data structure. So first in, first out, FIFO mechanism. So whichever the element you will insert, that will be get the first. Simple DR. Suppose if you want to buy some movie ticket, or if you want to make a reservation counter, we are going to be make a queue. Why? Because in a queue, whoever come to the first, they will get the service first. So first in, first out. So whoever step in the first, they can able to step out in the first. So FIFO, there is nothing but the FIFO. Queue is nothing but that one only. Whoever come first, they will get served first. FIFO mechanism. So this active MQ, RabbitMQ, these people followed the FIFO mechanism. FIFO mechanism. So that is nothing but the first in, first out. All the messages is nothing but a data, dear. Don't confuse on that. Whenever you are working with the message brokers, for example, let us say you are working with the HTTP protocol, request and response. What request consisting? Data only. What response consisting? Data only. That in the with respect of the headers, with respect of the body, everything is the data only. Similarly, here also, the RabbitMQ and your ActiveMQ, these message brokers will pass the data in the format of the messages. That's it. Message is nothing but a data. Don't overthink. So don't make unnecessary complications on that. Message is nothing but a some data. Consider that data your choice. You can create just in the form of the string format, or you can create in the form of the JSON format, or you can do some kind of a binary format also. Any kind of a data format. So that's will calling as a message. So that's where your serializations, deserializations come into the picture. So once this message brokers will prepare the message, you can able to deserialize at the client level. So how deserialization? That's a client choice. Maybe he can deserialize in the form of the string. Maybe he can deserialize in the form of the some kind of a JSON. Maybe he can deserialize in the form of the some object. So that's will called as a deserialization. So your message brokers, what it will do is they will store the data in the raw format. That raw format we are going to be calling as a messages we are going to be calling. So message is nothing but your data. That data will going to be added in a queue format. So whichever the data you are going to be keep on adding to your message brokers, they will create a queue data structure internally. They will insert that data in a queue format. Each and every data packet, the inserted data, that's we are going to be calling as a message we are going to be calling. Every time can we go for the message broker means no. So when you are going to be using the message broker is the optional. Not every application is not required for the message broker. So using your message broker is the optimal solution when you are not expecting the response immediately. Let us say you are placing an order. So maybe I suppose not to confirm the order immediately because I'm having the huge crowd. Let us say Amazon, Big Billion, say Flipkart, this sales was going there. That time, maybe I may not to acknowledge the user immediately, but I need to process the data. Asynchronously, I suppose not to disappoint the user. Immediately, I may not to process the data. But ultimately, I need to process the data asynchronously. So that scenario, we can go for the message broker. But your application is a lightweight application. You don't have that much heavy traffic. Then don't go for unnecessarily, don't introduce this message broker systems. Because message brokering systems involved whenever your application is a high latency applications like e-commerce applications, the two heavy e-commerce applications, banking applications, aeronautical applications, because like a consumer based applications, booking, ticket management bookings, IPL booking systems. So there your message brokers will actually help you. So using a message broker is a optimal solution when you don't have a immediate response you don't want to give, but ultimately you can able to provide. Customers can able to wait some amount of. So let's say I booked a ticket, I amount of time, maybe 30 minutes wait. So I can just verify order or booking confirm. Then you can go for the message broker ranks. Suppose if you are expecting the immediate response, immediate response, then you are going for you are going. So that's your message brokers will actually help you. So while dealing this message brokers, having two types of modeling here. Like Can you hear me?
Yeah, I had
Hello?
here.
Yes, sir.
Yes, yes.
I'm not sure why today network is giving this much trouble. Yeah, I understood.
Voice is low.
Yeah. So, yeah, just give me a minute. I will just reconnect because I'm facing some network issue. I will change the network and I will reconnect. Just 2 minutes.
Okay.
I will rejoin. Okay, I think now you guys can able to hear me clear.
Yes, sir.
Yes.
Yes, sir.
Okay, yeah, I just connected with the direct line I connected. Okay. Yeah. So just a quick refresh. So whenever you are going to be using any kind of a message broker, so this message brokers is initially offered from your ActiveMQ, RabbitMQ. So these are the queue-based message brokers. So which is nothing but, so they will create a queue. Whatever the data you are going to be create, that will going to be inserted. That will going to be inserted in a queue. So at the development of this message broker, we are having only one model that is the point-to-point model here. Point-to-point model. So because every framework will going to be designed based upon some design patterns. Let us say Spring MVC, that is some design pattern, Spring MVC design pattern. So its internal user singleton design patterns like the same way. So these message brokers also designed on a design pattern called as a point-to-point design pattern. That is a pub and sub, publish and subscribers. People will going to be considered like that. But initially, the message broker introduced the point-to-point communication. So this ActiveMQ or RabbitMQ is actually developed based on the model called as a point-to-point model, which means, let us say I have an application. So I don't want to communicate directly to the another application with through HTTP protocol. So then what we will do is we'll use this RabbitMQ. So this RabbitMQ will going to be create a queue for the specific client. A queue for the specific client. So let us say I have an application one or mobile application or one thing. So this will going to be create a queue for a specific client. Suppose if you are having the another client, definitely I need to create another queue, because this is the point-to-point communication. Another queue I need to create. So this queue is for the another client. So like this, if my number of clients is growing there, definitely my number of queues is going to be growing there. So that is the point-to-point communication. So once as an app, if I insert the data in your RabbitMQ, or if I publish a message in your RabbitMQ, that will be inserted in a queue. So that queue is dedicated to the particular client. That queue is dedicated to the particular client. So now my number of clients is growing there. My number of queues also definitely will growing there. So this is where actually people faced a lot of issues, because that will become a juggled mode. So a number of clients, a number of queues, if something goes wrong, which queue is failing, which client is failing. So this is actually mixed up mode. This is actually causing an issue. So this will call as a point-to-point communication. At the time of the designing your event-driven systems through a message brokers, these people, ActiveMQ people, RabbitMQ people, followed a model called as a point-to-point model. They just followed. In this point-to-point model, your every message broker will going to be having the queue. That queue is tightly coupled with your client. Your number of clients is growing there, your number of queues is going to be growing there. So that's where your message brokers will going to be sometimes will, if your message broker is a down, your queue is going to be down. So that's where your application is not become a more reliable. It will, I can't able to trust my application, because when it is going to be work, when it will not going to be work, I can't able to define. So that is where LinkedIn people came into the picture. They just developed their internal message broker system for their own purpose, because in a LinkedIn they're having a huge customers they have to deal all those things. So they want to go for the event driven mechanism. At that time they're having the ActiveMQ. So they have a RabbitMQ. They initially worked with the ActiveMQ and RabbitMQ, and they face this challenge. Whenever the number of clients is growing there, like mobile apps, web apps, some kind of installation apps, something is growing and growing, the number of queues is going to be growing there. The handling of this message brokering will become a difficult. So that's where they introduced another model, is the publish and subscribe model. These LinkedIn people introduced publish and subscribe model. Publish and subscribe model. So Active and RabbitMQ people followed the message broker concept, that is the point-to-point communication. So in a point-to-point communication, what will happen is it will between only one producer and one consumer. So basically it's a one-to-one relation. It's a simply one-to-one relation set between your producer and consumer. So whatever the message you send, each message is going to be tightly coupled with your queue. So that queue is going to be connected with the client. So whenever your client 1, Q1, client 2, Q2, client 3, Q3. So like that, each and every queue is tightly coupled with the number of clients. So that will actually going to be increasing the burden on your application. So one-to-one communication. To avoid this kind of issue, generally this kind of a one-to-one communication will use in a banking systems here, because in banking systems only one time you need to perform the application. Each message in the queue is only set to the one recipient. So once you do any kind of a payment, so that that a transaction has to be done only one time only. So that's where that dedicated queues you are going to be integrating with in your banking system. So at that time, widely this banking people will use this RabbitTime queue because of this reason only. So because this is a point-to-point communication, one peer, one one peer and one consumer. So one people will going to be produce, only one people can able to consume. To exchange the data in a more secure manner, so this peer-to-peer communication will just call, that is a point-to-point communication. Your queues will going to be come into the picture. Queues will going to be come into the picture. So that's where generally in a banking applications, this will actually help you. So this is actually understood by your LinkedIn people. So these people want to introduce to another topic, that is the publish and subscribe model they introduced. In this publish and subscribe, the data is considered as a topic. A topic is a serial of data. It is not dedicated to any client. So what these people followed is, if you see, this is the one-to-one mechanism. App will going to be communicate with the RabbitTime queue. RabbitTime queue will going to be insert the queue. Queue will going to be communicate with the client, which means consider this is the master. Master, this client is a slave. So master is going to be publishing the data in a queue, then slave is going to be consuming the data. So your master is nothing but your application, nothing but your producer. Producer is going to be publish the data in a queue. Then your client is nothing but your slave, is going to be consuming the data, because one master, one slave, one master, one slave. So that's how your app is going to be tightly coupled with your queue, and your app is going to be tightly coupled with your client. So this is the master and slave. Now, if you carefully observe, master will push the data, or master has to be share the data, then only slave can able to consume the data. So this is the point-to-point communication. So because master have a fully control on the client here. If master is not giving the data to that particular client, or if master is not giving the data to the particular queue, let us say, so this app is not considering the queue, it is not giving the data to this queue, client 2 is failing, which means master have a fully control on that client, is a tightly coupled. When master give the data to that particular queue, then only your slave can able to capture the data. So this is the master and a slave approach. So nothing but a top to down approach. So master will going to be give the data to the queues, then only queues going to be consuming the data through the client. So this is observed by the LinkedIn people. So those people will going to be came into the publish and subscribe approach. In this publish and subscribe approach, what these people do is, boss will do one thing. Same master, nothing but your app, will not going to be pressurized to any kind of a client, and will not going to be insert anything, will going to be moderate the application. Whatever the data we want to insert, that will going to be insert in a topic. Topic is nothing but a simple data, dear. Topic is nothing but a data. So whatever the data you want to share with your any kind of application, so that's you are going to be inserting in your topic. Now what this master will do is, it doesn't bother who accepting the data, who using the data, it will not involve. So just it will going to be insert in a topic. It will insert the data in a topic. Now, whoever require the data, they will subscribe. They will subscribe with this topic. Now, master don't bother. So master will just insert the data in a topic, and whoever need the data, they will just subscribe. Let us correlate with a simple real-time example. A simple thing, dear. Let us say you people I want to share some soft copy with you, or I want to share some kind of a documents with you, or I want to share some kind of a material with you. What I told is, each and everyone come to Ashok IT at some point of time tomorrow morning 8:30. Don't come. I'm just telling an example. tomorrow 8:30, I will going to be personally, I will share the data, I will share the material with each and everyone. That is a point-to-point communication, because I'm a master, you are the consumer. So I need to give the material to you. That is a point-to-point communication. So which means you will get the material when I'm available. Are you getting my point? In a point-to-point communication, you will get the data when master available. So the same way, you will, if I want to share the material personally with you, I need to come to the Ashok IT, and you guys also come to the Ashok IT. I will going to be distribute each and everything in a individually. So that is the one-to-one, point-to-point communication. That is the RabbitMQ mechanism. So instead of this, what I told is, I will, let us say 60 people asked me, we need a material. So I prepared the 60 people material I prepared. I just hand out in a Ashok IT admin. So I just told him, so boss, whoever come and whoever tell my name, because not everyone, whoever tell my name, so just give this material. So this is the, whoever subscribe to me, whoever belonging to me, they will directly get the data. They don't require my presence there. So just I will push the data. Even if I'm available, if I'm not available also, you can get the material. So similarly here also, publish and subscribe. So app will just publish the data in a topic. The topic is the media who will save the data. So just app will going to be publish the data. Whoever need the data, they will just subscribe. They don't bother whether the app is available or not, whether that app is particularly sharing this data or not. They don't bother. So whoever need, the clients will going to be simply subscribe the topic. The topic is the media who had the data. They will get the data. So this will call as a distributed message brokering. So a point-to-point communication is the one-to-one communication. So this is a publish and subscribe is the one-to-many distributed. So now you no need to wait for the master, nothing but the whoever producing the data, you no need to wait. So they will just one time they will produce, whoever the clients need the data, they will subscribe the topic. Now see, clients, whenever they need the data, they will subscribe to the topic, they will get the data. So this we will call as a distributed message brokering, because your data was distributed between the multiple clients, your data was distributed to the multiple channels. So that's will call as a topic we are going to be calling. So now see, queue is followed by the point-to-point communication. Publish and subscribes will use the topic. Queues are dedicated to the client. Queues are the dedicated to the client. Publish and subscribers, we are having the topics. They are not dedicated to the client. They are distributed to the client. Any number of clients can able to subscribe to my message. So I can able to get the data. So now I don't bother about the app. I don't bother about the publisher. So simply publisher will going to be publish the data into the topic. Topic is nothing but the media who will hold your data. So these are subscribers is nothing but your clients. So whoever will going to be subscribed, so they will going to be get the data. So this is the actual idea behind the Kafka. So Kafka is introduced to implement the publish and subscribe thing. Before this also we are having, that is a point-to-point communication. In a point-to-point communication, we are having the queues. Queues are dedicated to the client, and those are tightly coupled with the master. Master has to be give the data, then only slave can able to consume the data. But here, master only publish the data one time only. In future, let us say if you see, now today I'm having only 2 clients. Tomorrow third client is came to the picture. Now I need to create a third queue, and I need to tell to the master, hey master, a new queue was created, use the data to that new queue also. Then only that third client will going to be coming to the picture. But now see, in a Kafka, so whoever, maybe today 100 subscribers, tomorrow 200 subscribers we're going to be getting. We no need to bother about this. So distributedly, the data will going to be shared between all the clients. Only one time publish will going to be happen. Whoever subscribe this to this topic, they will get the data. So that's where this publish and subscribe channel become a more and more accurate in sharing the data. So that is where your Kafka came into the picture. The main purpose of the Kafka is to implement the publish and subscribe mechanism. So that is where Kafka came into the picture. So that is Kafka is actually introduced by your LinkedIn channel. So got at least a context about the why Kafka introduced? Before Kafka also we are having, but the communication is the
Point to point.
Kafka introduced in a
Publish and
publish and
subscribe.
subscribe. Yeah. So in a point to point, what we are having?
So,
Queues.
producer and
Point to point communication, we are having the queues we are having. But publish and subscribe, we are having the
Topics.
topics. So one topic can able to subscribe any number of applications. In the future, your number of applications grown also, we no need to bother because only one time we'll publish the data. But coming to the point, the master has to be no new queue you need to create, new app you need to tell. So that is where you are going to be getting. The best example, this one is your e-commerce applications, airline systems, all those things. So your message queue have a one-to-many relation. And simply, if I want to tell, this is the one-to-one relation. One-to-one. So this is one-to-many. Only one time you will publish the data. Many subscribers can able to subscribe the data. So that's where one-to-many will going to be happen. So that's where topic will going to be coming to the picture. A topic is a media for your data. Whoever subscribe to this topic, they will get the data. So that's where clients we are going to be introducing. Got it?
Yes.
Sir, one doubt on sir.
Yeah, go ahead.
So in the point to point, if I'm understanding correctly, there are more number of producers sending messages to RabbitMQ. Okay, those messages will go to one queue or many queues.
That is the only point, right? One-to-one. If a number of producers then going there, number of queues is going to be going there.
That means one queue for one producer, right?
One queue for one producer. Yeah.
Okay. In the other end, one client or one consumer for one queue.
Yes.
Okay, that means it is tightly coupled between producer and consumer and the queue.
That is what one-to-one.
Okay. Okay. In the other way, publish subscribe model. So producers and consumers are decoupled, but that consumers can consume messages from more than one topic, right?
More than one topic. Yes.
But in that case, there will be double time processing, right? Okay.
Double time process means you need to think from the publisher side. So because in a one-to-one communication, so each and a publisher has to aware the number of queues. But publisher only one time publish the data. But this is subscription, client anyway has to put the effort. So client side only one time effort only. I mean, sorry, publishing side only one time effort only. But the client side, client has to subscribe. That is that anyway you have to keep the effort.
Okay. Got
So now in a
Sir,
one-to-many.
one question. Sorry for the interruption.
Yeah.
I mean, Kafka can be used for bank applications as well, or only we need to go with RabbitMQ?
That's what I'm giving the justification out here.
Okay.
So once this was because I just told as example one-to-one, point-to-point. Now every banking application is a Kafka only. But now here what topic will do is, so every topic we are having something called as a IDs, specific IDs we are having. So with that ID, we can able to manage the topics also. So after Kafka is actually increased their latency and security, so you can able to implement point-to-point communication also in a Kafka. So that's where banking applications also using the Kafka. So nowadays, any application can able to use this Kafka. So that's the reason now RabbitMQ, ActiveMQ is having the less priority compared to the Kafka. So even banking applications also, we are using the Kafka. No limitation on that. Okay.
Okay, sir. Thank you.
Yeah. So like this, we are having a lot of companies, and even nowadays, once the cloud was came to the picture, we are having the AWS. AWS is introduced something called as a SNS. It's like this is also a Kafka only, SNS, nothing but this is also message broker. So simple
SQS, I
notification
think.
service. Sorry,
SQS, I think.
SNS, simple notification service. SNS, dear. This is the message brokering service.
SQS, I think, is not SNS. SQS is.
You are telling a simple queue service.
Yes.
So yeah. So this SNS will actually one of the. I'm talking about the message brokering. So that SNS only support this publish and subscribe. Kafka as a service is the SQS. I'm talking about the direct message brokering, which will going to be support the point to point and all those things. So this is a queuing system. So this is alternate for your only Kafka distributed managing. But if you want to get both like a point to point and as well as this distributed, SNS is the best suitable simple notification service. So generally we use this SNS, and SQS we use for the high latency applications. Yep, both is going to be having their own thing. It will only support the distributed message queue services, but this will going to be support all notification services, message brokering. You can just see. So your SNS is support for all message brokering, message queues, all those things. So your SQ is only all these things. See, all three are SNS, SQS, Amazon MQ, all for this message brokering only. But this is the basic architecture. Like this is the you can consider core service here. SNS is a core service on top of this SQS, on top of this MQ. Okay. Yeah. So now this is what actually event-driven mechanism was came into the picture. So this is all about the theory. Now, just as a kickstart, I'm going to be show how you can communicate with the Kafka and how you can going to be set up your Kafka in your system. Then you can able to work with your application with the Spring Boot. So that's we will see. So as I told, this is a two parts here. So today I will show integration with the part one. So in a part two, I will going to be explaining something called as a Angular. I'm going to be integrating all those things, end-to-end application. I'm going to be explaining. So that's I'm going to be telling about in a part two. So that's we'll see in the interest of the time. If both will be completed in the same today itself, I'm going to be showing the both. Otherwise, part two we're going to be discuss either tomorrow or next weekend. I will tell you. So let us quickly jump into our Kafka installation, and we'll see how we are going to be working. So you can just simply download the Kafka. You can just from your Google. So these are the different things. Generally, people Kafka means that they don't want to set up all those things manually. Simply, they will tell, "Hey, install the Docker and get the Kafka Docker image." But what my funda is, everything will take about the Docker. It will start the Zookeeper, all those things. But put some amount of a time basic, so then you can easily work with the Docker also. No issue on that. So this is the Kafka here. So you can just simply download. So this is the source code. If you want to, because every open source tool, they will share the source code also with you. Suppose if you go for the Maven, they will share the source code. If you go for the Gradle, they'll share the source code. Suppose if you want to download the Tomcat, they will share the source code. So if you want to go for the source code, you can just go to the source code. And distributed means a packaged one. So you can just take any kind of a package. So this is initially give the tar ZZ. This is nothing but a zip file only. In a Windows, it is a zip file. If it is a Linux, it is the tar file. So you can take anything 2.12, 2.13. You can just click at this, then it will going to be download. So I think I already downloaded that one. Softwares. So you can see I downloaded 2.12 TZ. So this is the tar file. So if it is a Linux, so just with the command you can able to extract. If it is something called as a Windows, you can just right click extract. You can just see something called extract, because as it is a tar Z, direct Windows will not support. You can use the 7-zip. 7-zip is one of the extracting tool. You can use this and you can just click the extract to something or extract here. So once you click here, it will extract. So and I just extracted like this Kafka. So that this will give like this. So just you need a 7-zip. 7-zip is also open source tool here. So it will actually help you to extract your zip files, all those things. You can just download .exe file, double click, it will going to be down install. So just you can go to that TZ, you can right click, install. That's it. If anyone want to practice along with me, you can quickly download also. No issue on that. Just you need to visit that Kafka download, that TZ file, get the 7-zip, download that tar file, right click, extract here. It will going to be give the Kafka. So just I created the Kafka file like this. So once you got the Kafka, so the folder like this here. So it's always better to create a 2 folders. That is the Kafka logs and the Zookeeper folder. So create these 2 dedicated folders manually. You need to create these 2 folders. So Kafka logs and Zookeeper. Or I will do one thing. I will delete this. We'll do from scratch. Softwares, I'm having this Kafka. So just right click, 7-zip. So extract to this Kafka 2 thing. So this will extracted like this. Again, this is the Kafka. So this is the Kafka.tar we are having. Let me 7-zip extract here. So this is the Kafka folder. Okay. So let me keep in a directed D drive. I'm just keeping my folder name is the Kafka, because sometimes you will get an exception. Folder name is too long, so those kind of exception. To avoid that one, so keep your folder name is the Kafka. That's it. Remove that underscore 2.3, all those things. Remove that one. So just to create a Kafka. So it will looks like this. It's recommendation, not mandatory. It's recommendation. Why that is? If you just go to the config, if you open the Zookeeper.properties, any question here? Someone is asking. Nasimha?
No.
Okay. If you see, there is something called as a data directory. So in this, what will happen is it will store some kind of a topic information, all those things it will store. It will create some kind of a data. So generally it will take a temp directory. So to avoid this temp, because temp folder, always your Windows will going to be clean your temp, all those things. So that's the reason to permanently store our data to all those things. So my recommendation is try to create 2 folders. That's your choice, dear. Wherever you want to create, you can create. But recommendation is, because all the Kafka related things keeping in the same places, give a good choice. So I will just create a new folder. First one is the Kafka logs, because future if something goes wrong, we need a log files. We'll tell to the Kafka, create all the logs here, and create another folder, Zookeeper. Okay. So I just created the 2 folders, Kafka logs and Zookeeper. Now copy this path. I will just keep this Zookeeper. So now go to your conf file. First to open the server.properties here. First open the server.properties. There you are having something called as a logs. You can just see there is something called as a log directory. Let me check the logs. So this is the logs directory. So what I will do is D drive Kafka folder. This Kafka logs I just created. That's it. So this is in a server.properties. And go to the Zookeeper.properties. Now we need to tell where Zookeeper data is there. So now I will just keep this. It's not a Kafka, it is a Zookeeper. So d:/Kafka/Zookeeper. These are the two folders I created. Following me? Any confusion?
No. Good.
Okay.
No.
Everyone had a breakfast, right? Or need a break? You want to have a breakfast?
No, sir. Go ahead.
Okay. Yeah. So these are the two things. So now coming to the Kafka ecosystem, dear, little bit I want to correlate, because if you people don't have a knowledge, that's okay. But if anyone attended my Spring Boot batch, all those things, I just want to correlate it with the Spring Cloud. In a Spring Cloud, external microservice communication, we use something there. Is anyone from my batch, Spring Boot batch? For external microservice communication, what we used?
Scene client.
That is internal microservice communication. External microservice communication.
REST template.
REST template.
No. External microservice communication.
Eureka.
Something.
Eureka is a register service.
This is a discovery service for internal communication.
Config server.
CN
So-
client is also doing external communication.
So API gateway we just used. So I'm just explaining the terminology here. So API gateway we are using. So with this API gateway will actually help you for a external microservice communication. Why? Because maybe a lot of applications will going to be communicate with our microservices. So instead of exposing that host number, port number, all those things, we'll use this API gateway. So earlier Joule proxy that is deprecated in a Spring 2.7 onwards. So now Spring Cloud Gateway we are using. So that API gateway we used. So the functionality for the API gateway is to avoid the hard coding of all your host name and port number, multiple microservices. You can able to access through the same thing. In Kafka also, when I create a topic, this topic can be divided into a partitions there. I will explain what is the partitions, because I don't want to go theoretically these concepts. I want to show everything is a practically. So this Kafka will actual topic you can able to distribute it into a partitions. So ultimately a single topic can consist a number of partitions. So that's a topic with a number of partitions we are going to be calling as a cluster we are going to be calling. In this cluster, multiple partitions will going to be come into the picture. Each and every partition will have their own unique IDs, their unique offsets they are having. We'll explain. No need to worry. What is a partition that I will explain. So once we see practically, then I will explain. So this scenario, what will happen is every partition will have their addresses. Now, identifying these addresses based upon the partitions a little bit challenge. Like in a microservices, my microservice 1 running on the 8080 port number, microservice 2 8082 8083. So future, if my microservice port number changed, so this service communications will going to be fail. So that's the reason what we are using. We are using the API gateway. Through this API gateway, logically we are going to be communicating this all microservices. Now that scenario, in a future, their port numbers change also, we don't have any issue. Similarly here also, a topic can consisting of the number of partitions. Every partitions will have their unique IDs and their unique addresses. In the future, if their unique IDs and addresses got changed also, I have only reference of the topic only. As a client, I will just subscribe the client only, but still I need a partition. To retrieve these partitions logically, internally, Kafka use the API gateway called as a Zookeeper dear. Simply, Zookeeper is a API gateway. Nothing more than that. Zookeeper is simply API gateway to identify your Kafka cluster names, because once the Kafka server is started, it will create a number of clusters. Clusters is nothing but the number of topics, combination of a topics, combination of the partitions. So in the future, I need to identify that particular ID, particular topic, little bit difficult. So to logically identify, your Zookeeper will going to be come into the picture. So Zookeeper is a API gateway. Simply Zookeeper is a API gateway to identify your partitions topics internally. You will not do anything internally. So this Zookeeper will going to be actually helps to the Kafka to identify these Kafka clusters. So that's where, so first you need to start the Zookeeper. So once your API gateway started, then you can start the Kafka server. So because Kafka uses Zookeeper is a API gateway to identify your topics, all those things for a external application, external client communication. So for that, you need to first start. So that to Zookeeper properties you can able to configure. So you can, if you want to by default it will start on the port number is a 2181 here. If you want to change the port number, you can change the port number, all those things. The directory is this one. Suppose if you want to admin configurations, if you want to mention, you can able to do all those things. So that's, you can just use this Zookeeper.properties to configure the Zookeeper. So first I need to start this Zookeeper. So for that, if you go to the Kafka bin folder, by defaultly, it will give all the sh. If you are using the Linux environment, you can use this Linux .sh things. So Zookeeper.server.sh. So you can use this sh. But I'm using the Windows. So that's the reason I'm going a little bit step into the Windows. In this Windows, you are having all the batch files you are having. So those for the Linux, this for the Windows, batch files for the Windows. So this you can able to use this Windows. Now there is something called as a Zookeeper server.start.bat. So this I want to start. So this I want to start. So that's the reason little bit challenge here. Suppose if I just open the command prompt here, if I just start the Zookeeper server.bat, you need to give, see, it is giving how you can usage is server.bat. You need to give where your property file is there. Where our property file is there, that is available in a config folder. So Zookeeper properties. So now I can give Zookeeper server.bat space. So this is where my so my Zookeeper is started. It is started in a 2181 folder. So by default, it is going to be started in a 2181 folder. 2181 port, it is actually started. Okay. So there is no visualization. So if you are able to see this one, you can see binding to the 2181 port number. So it is actually started. So once you start this Zookeeper, then only you can able to start the Kafka. So how you can start the Kafka is, so Kafka need a server.properties here. Zookeeper need a Zookeeper.properties. Anything related to the Kafka, you are going to be configuring in a server.properties. So this is server.properties you need to give for the Kafka. So server.properties, let me copy this. Now let me go to the same bin Windows. So here I am opening the command prompt. So let me give a, you can just see there is a Kafka server start.batch file you are having. So Kafka. Yeah, so Kafka server start.bat. So this batch file will help you to start the Kafka server. So you can just use Kafka server start.bat. I'm just hitting the tab here. Tab. This one, server start.bat space. You need to give your where the server.properties available. So I'm just giving the Kafka config server.properties. That's it. Now it will going to be start your Kafka. So now see, so these all are just information here. Don't think this is some kind of error all thing. This is just information. So it is started on the 9092. Can just having your all those things. It is having the 8081 port. It is the first it will look for the Zookeeper. You can see it will first look for the Zookeeper. It is by defaultly it will going to be communicated the 2181. Suppose if your Zookeeper is running on some other port number, you need to tell to the Kafka through your server.properties. In your server.properties, there is something called as a Zookeeper connect port, you can see Zookeeper connect. So you need to change here. So by default, it is running on the 2181. So you don't need to change. Suppose if you change the Zookeeper port number, you need to change here, because without Zookeeper, your Kafka will not run here. Remember that, because Zookeeper is the API gateway for your Kafka. Every message brokering or every event is managed by the Zookeeper. That Zookeeper will going to be passed to the Kafka. So that's where your Kafka need a Zookeeper. Without Zookeeper, your Kafka can't able to start. So these is the two things. So these are two things you need to do. So first you need to start the Zookeeper, then you need to start the Kafka. So to reduce your burden, what people generally explain is they will just install the Docker. They will tell, hey, get the Docker image of the Kafka. So then Docker image will going to be configured, all those things. So instead of that, you need to know what is the internals. So that's the reason just I showed how I can start the Kafka, how I can start this Zookeeper. So now, so once the Kafka is started, so now I can able to see all my, I can create my topics. I can able to see my topics, all those things. To perform any kind of a topic operations, to visually see your topics, all those things, you are having something like Kafka client.batch you are having there. So if you see, you are having your Kafka client.batch. So it will actually help you. So if you see Kafka client metrics, it will actually help you to see all your client, all those things. Suppose if you want to create some kind of a topic, all those things. So you are having the Kafka topics.batch you are having. Kafka topics.batch. Oh, so this is the consumer, Kafka consumer. Like similarly, you are having the Kafka topics.batch. See, so this batch file will actually help you to list out the topics or to create the topics, all those things. For example, let me open the command prompt here. Kafka topics.batch. So if you just if you want to see all the topics, all those things, you can just give the ls. So then it will going to be give all the Kafka topics, available topics, all those things. If you want to create a topic, so you can just use the create topic. So hyphen create. Suppose if you just give the Kafka topics.bat, it will give the various usages. Now say if you want to create a topic, hyphen create, delete. If you want to just list, you can use the hyphen list. So Kafka topics hyphen list. Currently, it has to be bootstrap with the Zookeeper. So now you can just give the list that Zookeeper is going to be running on bootstrap server. Because Zookeeper, wherever it is running, you need to tell local host 2181. So then it will list all the topics. It's trying to communicate. Let me tell me it's taking some good amount of time. So if you just or you can do one thing, simply you can able to create the topic, then you can able to see. So Kafka topics.bat, you can just use the command create command to create a topic. So topic is the message holder. So you can just use the hyphen create. So you can use the Zookeeper, because you need to tell to the where your Zookeeper is going to be running. Local host 2181. So just you can use the replication factor, partitions, all those things you can use. And I can use the topic name as the demo I will use, or topic test I can use. Some topic test I can use. That's it. So Zookeeper is not recognized option. So local host. having this. Okay. Just give me a minute. Is it running on? Okay. So then I can do one thing. First, I need to give a bootstrap server because it is asking to me bootstrap the server. So let me give the Kafka topics. Let me bootstrap the server. Okay. So local host. So Kafka server is running on the 9092 here by defaultly. So you can check in your server.properties that port number is the 9092. So default is the 9092. So first I need to, because I'm creating the topics all links, I need to bootstrap the Kafka server. So let me bootstrap this one. So I can just, if you want to see all the topics, you can type the -- list. It will just bootstrap your Kafka and it will list things. So currently I don't have any topics. That's the reason empty I'm having. Suppose if you want to create a topic, so same thing you can just see Kafka topics. After bootstrapping the server, you can just use the create -- create. So you can just tell I want to create a topic. So then you can just give the some topic name. Let me do one thing. Demo topic. I will just give a demo topic. That's it. So that's it. And bootstrap server local host. That's it. I'm just creating the topic. So this is where we are going to insert the see. Now topic is created. So now you can just see the list. Same thing. Now I have one topic that is a demo topic. So now you can insert some data in this topic and you can see this into some other topic that you can able to consume. So to insert some data in a topic, you can use something called as a producer. So I will do one thing. I will take two things. Right side, I'm taking as a this one as a consumer here. So this is the producer. To perform the producing and consuming operations, to test all those things, we are having the two batch file. So you can see there is something called as a producer.batch, consumer.batch. So you can use this batch file to produce a message. You can use this batch file to consume a message. So you can just see, let us say Kafka. So just I can see the console. I want to first to produce a message. So I can just use this produce. I need to give a topic. In a topic, I can give some message. So let us say I will, the topic is a demo topic I created, which is nothing but in the topic I'm inserting. So this demo topic, I need to give some kind of a message. -- bootstrap server 9092. It's not a call, it's just colon. Or I will do one thing. I will just create like this. Above one is a producer. Below one is a consumer. Okay, so just this is the producer here. So Kafka console producer.bat topic. So yes, I will keep like this. Yes, I will keep like this. Okay. So producer is activate. Oh, we got something. What is the command we given? Kafka console producer. Okay. Topic is this one. Demo topic. Okay. I'm just to bootstrap the server. Sorry, we missed the local host here. Localhost 90. My producer got activated. So now whatever the message you will produce, that I want to see in this consumer. So for that, to see the consumer also, we are having the one consumer. Kafka console consumer. So you can just now this is the consumer. Consumer means if I want to get the data, it has to be subscribed to that topic. That's it. So producer will going to be produce the data. So that's you can just see the data here. So that's it has to be a topic consume. So you can just topic consuming, it is consuming. So which topic we are producing the data here? What is our topic name? What is our topic name?
Demo topic.
So demo topic. So now I need to consume. So from beginning itself, I want to consume. So that's where I'm just to give a flag is from beginning. So here you can give some kind of a timestamps, all those things also. So I just want to consume from beginning. Again, same, we need to bootstrap server local host 9092. So this is the consumer.
Bootstrap.
Okay, bootstrap. Yeah, still issue. Kafka topic from beginning. BEGINNING. Typo. Bootstrap server localhost 9092. Yeah, so we are subscribing. We are consumed. Pradeep, please go on mute. Pradeep. Pradeep, could you please go on mute? Yeah. So now it is consumed here. So which is nothing but we subscribe. Now you can just see, suppose whatever the message I will publish, that you can see in your consumer. So publishing, for example. So whatever I'm publishing, that is going to be coming in your consumer. So publisher is going to be publishing and consumer is going to be consuming. So like this. So how many applications will going to be subscribed to that topic, so that automatically they can able to consume the data. So here our agenda is in this place, Kafka console producer .bat, all those things. In this place, we can integrate the Spring Boot application, because this is a Kafka given that tool, that a producer tool it given and a consumer tool it given. So we are publishing and consuming through that tools. But if our Spring Boot application is there, through a Spring Boot application, how I can publish, how I can able to subscribe. Initial phase, we will see that one. Later that there is something called as, if the subscriber is down, how acknowledgements we are having, manual acknowledgements. That's also I'm going to be showing that one. So in this place, Kafka publishing and subscribing, instead of using this batch files, how we can use our Spring Boot application to publish. So that's we will see through a Spring Boot application. But here one thing. Suppose if I want to see all the topics, how you are seeing all the topics here? How I can see all the topics?
List.
We'll use that tool, Kafka topic list, all those things we need to use. Little bit difficult, right? Managing all those things, remembering these commands, all those things. So this we will call as a CLI. command line interfaces. So that was understood by the people. There is a one company who actually given a graphical user interface for your Kafka dear. So that is nothing but the conductor. You can use the conductor to see all your topics, all those things. So Kafka conductor, you can download this Kafka conductor. So you can see all your topics, all those things. So instead of using this, so goodbye to isolated, because that commands you need to remember, all those things you need to do. Instead of this, if you use this conductor, this will actually help you see how many consumers you are having, how many topics you are having. It will actually help you to debug also. Mainly people will going to be scared to debug the Kafka topics. So this will actually help you to identify debugging all those things. So this will actually help you. Initially, this is the open source here. If you are, some primary features, visualization, all those things, it will give. But debugging features, all those things you need to purchase. But just initially, it is going to be like a open source only. For our purpose, just we can use open source. So just you can able to download developers. You can able to just download conductor. You can just Kafka conductor download. You can just go to the desktop, Kafka conductor desktop. For if it is a Windows, it is a desktop. If it is a Mac OS, it will give that APM. So you can just go here and you can just download that one. So they will give a download for you. Okay, because already I downloaded, so that's the reason it is not showing the download button. So you can just give here. Already I downloaded, so that's why it is not showing. So more than an interface, yeah. So it's already downloaded. So for you, you will get some kind of a download button here, dear. So instead of a pricing features, you will get a download button. You can just download that one. So let us open my conductor. It's like this. It needs some kind of a login. So you can just use your first time it will going to be asked for some kind of a login. You can use your some Gmail account. Just given the Gmail account. So once you log in, it looks like this. So it will come like this, and you need to add the some kind of a Kafka cluster. Nothing but where your Kafka is going to be running. So you can just give a new Kafka cluster creation. So our cluster name, you can just give some kind of a cluster name. Localhost. So Bootstrap server, wherever your Kafka is going to be running, that's port you need to give. So what's your port? Kafka is running on by default 9092. Localhost 9092. And it need a Zookeeper also. See, it is asking the Zookeeper. So localhost 2181 Zookeeper. That's it. So first you can just see the connectivity here. Test Kafka connectivity. Yeah, connection is okay. So now you can just save. Once you save, you can see your Kafka connection here. You can just click here. Just click on this. It will open. It looks like this. Now see, it have a topic. Now we created a topic, right? Did you remember? What is our topic name?
Demo topic.
So that's you can just see here. So in a conductor, topics, you can just click here. This is the topic. So it is actually showing the two topics. Why? Because this conductor also will create one topic. So that is for a debugging purpose. That's you can neglect. But actual our topic is the demo topic. So that's the demo topic. You can just see here. So demo topic. You can see all the information. So like how many messages you are having. So I think we given the two messages, available here. So everything you can just see here. So one consumer you are having. So like a partitions, we didn't do anything. So these are the configuration when it is created, everything here. So this will actually help you. So this Kafka Connect will actually help you to see all your topics, all those things. Instead of using this boring CLIs commands, giving all those things, you can use the Kafka conductor. So this conductor will actually help you give all those things. Even if you want to create a topic, also you're having the create topic button here, you can able to create all those things. So that's how you can able to visually see. This will give a graphical user interface for your Kafka. You can see all the topics, all those things. This Kafka conductors is a very handy tool. So instead of doing all this Kafka producer batch, consumer batch, and if you want to create a topic, again going for the Kafka topic, create a Bootstrap server, lengthy thing. If you instead of your typing, you can just use this one. Yeah. So this is one of the handy tool when you are working with the Kafka. So you can see all the topics here. So now let's come back to our actual implementation. So in our implementation, what my requirement is, like how with a simple Kafka topic, you are going to be, let me take some, I will create this one, workspace. So like how you published through a batch file, how you consumed through a batch file your messages, in the place of this batch files, I need my my Spring Boot application. So I need to produce a message through my Spring Boot application, and I need to see the message. I can able to consume my application through the Spring Batch application. So that's I want to do. So for that, Spring Boot giving the extensive support for that here. So with it's a just a matter of adding. It's just a matter of adding a dependency. So it will going to be taking care about all those things. So let me do one thing. I'll just create a new application. So new project. So Spring Starter project. So I'm just taking, let me do one thing. I will just take this something called as, let us do some practical approach. Instead of giving the like this demos like a producer, all those things, not like that. Let us say I'm taking the order service. This is my order service. Consider order service is something called as com.bootcamp.order service. Consider this order service is a producer. So we are going to be produce the orders. Payment service has to be consume these orders. Based upon these orders, it has to be complete their payments. So that's I'm going to be taking. Order service I'm just taking. So next, so dependencies I need a web dependency, Spring Web dependency. That's it as of now. And I need a Kafka dependency. So see, Spring Apache Kafka, this is enough for us as of now. So when we go for some kind of a partition stages, then we'll see we need a stream or not. So that's it. These two dependencies added, and I'm taking the 3.1.0. There is a stable version. Next, finish. And similarly, let me create another new service also parallelly, Spring Starter project. So this I will consider as a payment service. So my package name is payment com.bootcamp. So that's it. And for this one also, I will just this already taken web and Kafka. These two things I'm taking. Two services I taken. One is the order service. Second one is the payment service. For both, I added the web dependency because we need to perform some operations, publishing all those things. I need a REST controller to see thing. I'm just taking this one. And I created some payment service. It's still creating. Okay, I don't know why it is taking this much time. Oh, wait a minute. It took a Gradle here. I don't require a Gradle. I will go for the Maven because Gradle some configurations will not work in my system because I used the this one. For ease of our doing, I will do Maven. Because you can continue with the Gradle also, but in my system there is some, because it's a company system, so I suppose not to have that configurations. Proxy configurations again I need to do. So let me create a Spring Starter project. Payment service. I will take a Maven, Spring Web, and Apache Kafka next. Yeah. And now let me create a Spring Starter project. Order service I will take. Here I will take order service. Both dependencies I'm
These
taking.
two services are we are publishers, right? We are creating.
No. Consider order service as a publisher, payment service as a consumer.
Oh,
Because I will publish order to the payment service.
okay.
So payment service need to consume my order details. Based upon that, it has to make a payment. Okay, so here so like this order service, this will become a publisher, this will become a consumer. Okay, so now first I need to publish a message. So for that, I need to create a producer. I need to create here. So to create a producer, first you need to define some properties in your application or properties. So because what is your Kafka, how you need to run all those things, you need to tell. So and second thing is you need to define a serialization. So at the time of a starting of a class, I mentioned one thing. So once a publisher publish the message, that is the consumer choice how it has to be serialized. Or publisher also can able to tell, because the message is the raw data format. In a topic, it will insert the data. That is a raw data format. What kind of a serialization? Because if you see this producer, it's by defaultly taking the string, because command line it is string, or by default it is taking the string serialization. In the future you need some kind of a JSON serialization or some kind of some other serialization. So which kind of a serialization this producer has to do, that you need to tell. So that's the reason first add those serialization in your application.properties. So what I will do is I will and you need to tell where your Kafka is going to be running also. So you can just spring dot Kafka Bootstrap server. My Kafka is running on a local host. What's the port number, dear?
9092.
Exactly, 9092. And now I need to tell spring dot Kafka dot. So this is the producer. There is something called as a, so these all are the different kind of options if you want to secure all those things. So I need a serializer, key first. Okay, yeah, so key value both I need. Key serializer I will take. Honestly, I didn't remember this serializer here. So that time only approach what I have is, because this is a class name I need to give. Nothing wrong, because I'm not the fellow who will buy hot. Go to the Spring documentation. They will tell what serialization class you can use. Not this one. You can just see. I just need a string serialization. This is a JSON serialization. If you want to, I want to go for the string serialization. Let me search for the string serialization. So this one, string serializer. I need this package here. Package. String serializer. I don't know the package. String serializer Kafka doc. This Apache Kafka dot. This is producer, but I need a string serializer. This one here, common. This I'm taking. So this I need. So I'm just keeping here. And the same way for value also, I will take the string serializer. That's it. So this is a serializer class we need to give. So this is a key serializer, value serializer. So you can just see Kafka. We are creating the Kafka producer for this Kafka producer. So these two things we need as of now. I'm just taking this one. That's it. And Bootstrap server. So this is nothing but your Kafka server. So that's what I just added here. So Spring is actually given a wrapper through application.properties. That's it. So save it. Now let us develop a producer. We need to create a producer. So to create a producer, so let us create some class for that. Let me create a new class. I will create a producer package also. Order producer. Some meaningful name I'm giving instead of giving the like a Kafka producer, demo producer. I'm giving the some meaningful name. So to create a producer, so practically, if you are not using any Spring Boot, if you are using the plain Java, so this class you need to extend here. Extend a Kafka producer. So this you need to extend, and you need to create your all the Kafka producer interfaces, all those things you need to create. But we added the Kafka dependency in our Spring Boot application. It's giving the lightweight wrapper, that is Kafka template you can use. By using simply Kafka template, you can able to create with your choice. So now I can just create a private final, let us say some Kafka template. So you can see this is the Kafka template coming from your Spring framework. So string key value pair also string. So that's I'm taking. Any guess why you are taking the string and string here? Just a guess. Key value. Because in application properties, serializations are the key value serializations are the string serializations. Suppose if you are using the JSON, you need to keep the object here, dear. Object. That's you need to keep. So that's it. And let me give a variable name is a Kafka template. So now, as because it is a final at the time of initialization of my order producer, I need to initialize this one Kafka template. I'm going to be initializing. So same thing, I will just keep like this. Kafka template I can keep. So this dot Kafka template is equal to Kafka template I will keep, and I will initialize this as a component. I'm just going to be creating. Save it. So now I need to create our message sending information I need to do. So this actually Kafka template internally extends your Kafka producer class. So this Kafka producer class have something called as a send message here. It have a send message. Now see producer.send message. So with this send message, you can able to send your messages. So basically this producer class is extended by the Kafka template. So that's the reason Kafka template.send you can use. That's it. So I will just take some method like this, public, some kind of a void message. Send a message I will take. So I need a message. So that's the reason I will just take some string. I will take simply string, let us say our message. What are the message we want to send to that topic that I'm just give. So Kafka template dot send your message. Whatever the message you want to send, you can just send here. That's it. Okay, and this needs some kind of a topic named here. Send need the topic, because which topic you need. See, it is actually asking for the topic also. So topic, you can just give some topic name. So what topic name? Do we have any topics here? We are having the demo topic, right? Can I use this demo topic? I'm using this demo topic. I will publish my message to this demo topic. That's it. That's it. So suppose if you want to display something, you can just display all those things. So that's it. I just send the message. So now this is my producer. So now I need to send some message. Simply I will do one thing. Let me take some controller. Order controller. Rest controller I will take. So let me do one thing. So public, I will just give something called as a return type is your choice. If you want to take some kind of a string or something, your choice. I will just take some kind of a string. Post message I will take. So now let me auto-wire order producer here. So this is the producer. I'm just auto-wiring or order producer. So now I need to, whatever the message you are going to be posting, so that's I need to post here. So producer dot, we created a method, this one here, send message method. Send a message. So I will take this from request body, because request body. So let me take something called as a message. So this message, whatever you're passing, that's I'm going to be passing. If everything looks good, I'm going to be rating. Message published, or whatever the message you're just giving. That's okay. That's it. So I take a request body. So-called Java developer, so-called Spring experts, which annotation I can use or which mapping? I'm using the request body. REST controller.
Post mapping.
Post mapping, because if you go for the get mapping, get method don't have any kind of a request body. So that's the reason I'm taking the post mapping. So I will do one thing. So simply send I will take. My created endpoint is a send I will take. That's it. So now this is my application. Now if I just run my application, so yeah, application is started. But yeah, so we have your producer. Okay, yeah. So now let us, it is running on something called as an 8080 port number by default. So let me take a postman here. So I'm just taking the postman. In this postman, you can just give. I'm giving some kind of a 8080/send I'm giving. So let me do one thing. Localhost 8080/send I'm taking. Post mapping raw I'll just take something called as a JSON. I taken string as this message, and the value is nothing but, let us say, hello from Spring Boot. We just developed the publisher here. So once you publish, that will going to be published into your topic. So probably you remember or not. So here there is a consumer is already running. So now our publisher is the, as of now, we didn't develop any kind of a consumer, just we develop the publisher. What is our publisher? Spring Boot application. Consumer, we can use this as a consumer. Later we develop the Spring Boot application also as a consumer. Are you getting my point? We are publishing message from the Spring Boot application.
Spring Boot.
That is your order service. Consumer still we need to develop, but first once we are confirmed with the publisher is publishing the message, so then we'll develop the consumer. So meanwhile, I can use this consumer as a testing. So now I'll just send the message. So now I just send the message. So now you can see I'm able to get the message here. This is what we sent, right? From our Spring Boot application.
Yeah.
Is our messages publishing successfully or not?
Yes.
Okay. Now, publisher is ready. So our publisher is a Spring Boot application. That is nothing but the order service. Now I want to treat payment service as a consumer. So now I need to develop a consumer. So now let us go to our application. So I want to treat this payment service as a consumer. So simply what I will do is I will go to this one. So let me create a new class order consumer, because I'm consuming the messages from the order. So consumers I'm going to be keeping, package name is, so that's it. So now I need to create this consumer. So first of all, for your consumer also, you need to tell where your application is going to be running. I mean, where your Kafka is going to be running, you need to tell, and you need to define that the serializations also. So that's the reason. So now let me go to the same. I will going to be copy. In payment service also I will keep. So localhost 9092. But here I need to add another additional property also, because 8080 already running the auto service. Let me pick another port, server.port. Some port number, suggest some port number dear. Any lucky numbers?
909. 8085.
Okay. I'm going for the 8087. So here, so I can just go for the consumer. So basically, this is not that much here. So you can just use the, like how they mentioned the consumer producer key serialization. You can just mention the consumer key serialization, value serialization. That's it. So this is don't require. You can just mention the producer itself, not a problem. Both will be a producer serializer will be affected on the both consumer as well as a producer side. So you can just go with your producer.key serialization property also, no worries. So that's it. And now come to the order our order consumer. Now I need to consume whatever the messages publisher from the order service we need to consume. So that's the reason. Simply you need to create an annotation that is a @Kafka listener. That's it. Because this is a consumer, it just has to subscribe. That's it, not more than that. So just you can create a method. Let me do one thing. I just create a public void. So I will just create a method called as a consume order. That's it. And which will going to be give some kind of a serialization is the message. I will give something called as a message I'm going to be giving. So now here, whatever the operation you want to perform, you can perform the operation. So what I will do is I will just give I will do one thing. I will just print like this. Message received from order service. Whatever the message I got, so just I want to give, I will just display that one. So now here, just you need to add a Kafka listener annotation. So this annotation, you need to tell which topic you need to consume. So just you can give the topic. So you can subscribe to the multiple topics here. That's your choice. So I will give some topic name. So where we are publishing, which topic we are publishing? Demo topic. So that's I'm just going to be keeping here. That's it. And whenever you are going to be consuming, consumer needs some kind of a specific group ID here. So because we are having the multiple clients, every client will have their own way of a usage of your application. Future something goes wrong, so you need some reference which consumer is actually failing the issue, all those things. So that's the reason you can create a group ID. So group ID, so that your choice. So you can just give some kind of a group ID. I will give a demo group or Spring consumer. I will just create like this. My group ID is Spring consumer. That's it, not more than that. So now you can just start your application, and once at the time of the starting of your application itself, you can see. I will do one thing. If I start here, it will actually little bit difficult to show me. I will go to payment service. So here I will just start like this. MVN Spring Boot :run. I'll just run the Spring Boot application directly through command prompt. Okay, so application was started. Now tell me, dear, how many consumers we are having? How many consumers we are having? Two consumers. One is the Spring Boot application as a consumer, and the second one is the our batch. So Spring batch, this is another consumer. So you can see this application, top one is a Spring Boot application. That is the consumer, this one. Now if I just go, now if you need to carefully observe, a new consumer is added, but I didn't do anything at the producer side. But the same thing, if you are working with the RabbitMQ or ActiveMQ, that is a point-to-point communication. Whenever a new consumer is added, you need to tell to the RabbitMQ and you need to create a new queue for the consumer. Hey, this is the new consumer I created. So this queue, you need to post the messages in this queue also. You need to tell to in a RabbitMQ. But a Kafka, you don't require. So because a topic already have the data, if any new consumer is came to also, they are going to be consume the data. So that's I'm just going to be adding. So now let me post the message. So the same thing. So let us say order electronics. So this is what I'm going to be posting. So now I'm just sending. So now see, I just published this message. I published order electronics published. So this is the message I published. So now you can just see in my Spring Boot application, I didn't got, which means something goes wrong. What wrong? Yeah, the thing is we didn't initialize this class. So you can simply do one thing at component you can mention. So then IOC container will initialize this one. So now let me restart our application. But one thing you can see is it already consumed your message. Order electronics, it is consumed, but Spring application is not consumed because we didn't initialize it that. You can use component or service, some stereotype annotation as per your requirement. Yeah, consumption was happen. Now it is subscribed to the topic. You can see demo topic. This is 0 is the partition here. So group ID is a Spring connection, you can just see. So this demo topic 0 is a partition. So that's what. So now it is subscribed to that. So now if I just send a message, so now I can just both I can show like this. So above one is a Spring consumer, below one is the regular consumer. Now let me post something. Order stationery. I'm posting order stationery published. Now you can just see message received from the order service. Are able to find here? Stationery message came here. And the same thing published in your client also. Now 2 clients is actually published. So that's you can able to check out in your topics also, in your topics, all things you are having. So now see 2 consumers is actually. So this is one is a Spring consumer. So this is the console consumer. I told you, right? Because in the future, if you want to do something goes wrong, all those things, this group ID will actually help you. So this Spring consumer is another client is created. You can see all the which it is actually a topic subscribed, all those things. You can just see all those things. So this is how you can able to publish and you can able to subscribe. Now see, let us say compare with the REST API. You are having the huge number of orders. It has to be communicated with the payment service. Payment service is not managed by you. You are placing the orders, payment service slowly responding. So if a payment service is slowly responding, if you go for the REST template approach, now you need to wait. Payment service is going to be giving some kind of a response, either success or a failure. A user user may not have that patience. But now see, so order service just publish. Immediately, if we didn't receive the message, then order service will going to be tell order in a process, come back a little bit later, come back. So once the order message, your payment service confirmed and it's received the message, and once the message is processed, this will call as acknowledgement, we will call. So with that acknowledgement, again you will give us some response to the order service, then you can tell order confirmed, all those things. Now remaining operations, so you can just tell to the email service or inventory service, you can do you can do automatically. So now order service no need to wait the confirmation from the payment service. If it is a REST template, it has to wait. But now it converted as a event-driven mechanism. So that's the reason order service no need to wait the confirmation from the payment service. Just it will raise an event. So once the event was completed, either it is a success or failure, order service will going to be decide. So then it will give the information. Meanwhile, remaining operations you can able to perform. To achieve this kind of high latency of your application, high availability of your application, you are using the message broker. But whatever the thing we did is, it's a very basic. So just to order service, microservice. So the practical usage, when you can really understand is when I integrate with some kind of a UI. So through a UI, once I actually place an order, there I want to integrate some kind of a WebSockets without refreshing, how you can see the dashboard is going to be updating all those things. So that's you can able to practically see that order application. And here another challenge is, let us say my order service is going to be working, payment service working properly, but my payment service is a failed. But I need to check some kind of a fault tolerance. That's where your retrace will going to be come into the picture. Your partitions slicing is going to be come into the picture. That is where manual acknowledgements is going to be come into the picture. So that's a fault tolerance. In a microservices, your Kafka plays a major role in a fault tolerance. So that fault tolerance segment, that end-to-end application implementation, that's I want to, in the account of the time of the interest, almost it's a 2.5 hours. I don't want to pressurize much on that. So that's will going to be check out on a next Saturday. We'll check out here. Tomorrow might not be possible for me. So next Saturday, part 2, we are going to be integrating with the UI. That is a very interesting. So now just we seen how a publisher subscriber with a Spring Boot application will be taken, but the practical real-time use case, like a fault tolerance. So what is the play done by the Kafka. So how you can update your messages without reloading your page from the UI side. That end-to-end approach, that a UI segment, that's we'll check out on a next weekend. Same link here. This link will not going to be changed. So we are going to be making the same link. So you can able to check out for the part 2 on the next Saturday. Meanwhile, can I get any questions? Any confusions?
Can I get the recorded video?
You can
Or-
just simply call the Ashok IT here. They will share. And this is uploading on YouTube itself. You can just freely get that.
Okay, sure. Thank you.
This code also you will get. You can just call the Ashok IT. They will give the code with you. I will just immediately share the code, that Ashok IT team.
Okay, sure.
Yeah, maybe in the YouTube online is there, right? We can go through.
I'm sorry?
YouTube online, it is up there already. Live is YouTube online.
Live. Yeah. Okay. Yeah, you can check out there also.
So one doubt, Harsha, actually, how the message is delivered in a real time, what is happening from consumer point of view? Is the consumer polling continuously in a specified interval, or how it is getting the message when we send the message?
Basically, that a consumer, it's not the polling. So it's actually like a heartbeat mechanism followed by the RabbitMQ. So what consumer will do is consumer interval we are having. Every 10 seconds or 30 seconds, it will just check is there any topic is going to be there or not. Or once any new message inserted in a topic, this topic will going to be given notification to all the consumers. Consumers will never poll. That is again a memory leakage issues will going to come to the picture. Whenever message published to the topic will give a notification to all the subscribed consumers. It will push the message. So there it internally having some kind of a bridge. Zookeeper will going to be continuously poll that one. If you just see, so Zookeeper is going to be continuously polling that one. So any new consumer came into the picture, so Zookeeper will going to be take care about this. A new message was came here, Zookeeper come into the picture. It will communicate with all the consumers. It will publish the message to all the consumers.
Sir, all consumer means with it, that message.
Whoever subscribed to the topic.
Okay. Okay. Understood.
Yeah.
So I have one question.
Yeah.
Actually, whenever we run the Kafka server and let's consider we start sending the message and messages are getting consumed, and
right.
After that, if we stop the Kafka server, then again if I want to run it, so then I need to clear the temp folder in my directory. Why is it so? I mean, I'm not getting the proper solution. Basically, whenever I try to start the Kafka server again, it will not get it is not getting started. And as soon as I clear that temp folder, I mean delete that temp folder, so it is starting again.
That is the reason at the time of starting, I told you, so update this log files, all those things. Data directory, these things. Why? Because that's not the issue of the Kafka. That's the issue of your this one Windows. So what Windows will do is it always log the temp folder. Day to day, 24 hours, it will going to be log the temp folder. If you want to use again the same folder, your Kafka don't have that privileges on this Kafka. So then two options. Either run your command prompt in administrator mode, then without deleting it will going to be run. Otherwise, change this data directory to your local folder. Instead of using the temp folder, change this one. Then you no need to delete all those things.
All right. So it means if we don't do so, so the temp folder will automatically get created if we are starting as a new server.
New like a server.
And whenever we try to access it again, it will be directed to that same folder only, right?
Same folder only, but your Windows will lock a temp folder every 24 hours.
All right. Got it. So I need to change the directory itself.
Directories, yeah. Or you can, while starting the Kafka server, you are opening the command prompt, right? Open the command prompt in administrator mode.
Okay.
So run
And
as
whenever
administrator.
and whenever I need to start the Kafka server, every time I need to change the directory, or I need to do it once only.
Only once only, dear.
All right.
That's the reason we are adding in this properties file only one time. Because in a
Got
real
it.
time, every time changing means that is a little overhead bed, but no one will like it.
Yeah. Got it, sir. Thank you.
Yeah.
One more doubt. What
Yeah.
happens to the message once we consumer read the message? It will still there or on the topic, or it will removed option?
That's depends upon this one. So in your server.properties, how much time you want to mention. So that's depends on this one. So how much time I want to save the message, whether it is a 1 hour or 2 hour, 3 hour. So that's you can just see.
Okay, retention.
Yeah.
Hi, sir. I have one question.
Yep.
Sir, it's Kafka is like JMS because you haven't used here JMS configuration, or that's different from Kafka.
JMS is a different, right? That is a Java messaging service.
Yeah.
Here a use case like that, but a JMS is not a pub and sub here. I can say JMS only have a capability communicating with the two Java applications. That's it. That is a connector between the two Java applications. But Kafka is a platform independent. So clients is going to be increased. This is a distributed mechanism, but internally, I can't say there is a relation between the JMS and Kafka. Both are different. That's a message we can't compare also.
Because, sir, in mostly, if you use any queue, MQ, there will be a JMS configuration. That's why I just got confusion.
That's the reason, because in a MQ, there is a point-to-point communication.
Yeah, right.
So that is a platform dependent. So you have to create the queue. So, but Kafka is a platform independent.
Okay. So, sir, how if we do any payment, then how it will be we will get any success or failure from the GPS, or how it is?
That logic you need to do in a payment service. So now we got a message. So let us say that's in the next segment I will show. Once I cleanly develop a UI, you will get that clarity. So in a payment service, that logic. So just we converted our microservices as a publisher and subscriber. Now the logic is appending. Now I received the message from the order service. Based upon the order ID, I need to process the logic. So whether he had the amount or not. Once the payment is success, I need to acknowledge that message. Once the acknowledgement was happened, order service is going to be confirmed. Okay, the payment is success. So then we are going to be placing the order successfully, and remaining operations like sending the event to the email service, inventory service, we are going to be doing that one. So that business logic we need to write manually.
Okay, sir. Okay.
Yeah.
Also, sir, one more question. If we have do any payment and it will be a pending, then sometimes at point-to-point connections, if we restart our MQ, it will be a delivered success or failure. Is it same in Kafka also, or it is directly give our like failure or success?
If you restart, your acknowledgement depends here. So if your payment is a success, Kafka will acknowledge. So whether the payment is successful or not. So same like a RabbitMQ only. It will success or failure, it will tell. A transaction based.
Okay, sir. No, if our service is not working, then it will be going at the payment pending state.
A
So
pending state, once your microservices are restarted, at the time of a restarting of your microservice, you need to acknowledge that. So based upon that acknowledgement, it will tell, okay, payment is success or not. At the time of a starting of your service, you need to check your business logic, whether this order ID is a confirmed or not. So then if it is a success, so then you need to acknowledge. So then you can tell to the order service. That's the business logic you need to do manually.
Okay, sir. Okay.
Yeah.
So by any chance, in the next session, if we get a chance, then please you like tell us like that use case also for if we stop the any microservice, then it will go in a pending state, or it how it's acknowledged and how it works.
Yeah, that's I will try here, because now see, we started the session with the 70 people. Now we are having the 46 people. So I need to take care about that account of other people also. So because people have a less patience. So if I go beyond the 2 hours, they are not showing that much. That's the reason. If time possible, I will definitely show that one. I have that also in my mind. So if time permits.
Okay.
No
Okay,
worry
sir.
on that.
Thank you so much.
Yeah.
Sir, one more doubt, sir. So right now we did everything in the local machine. Let us say if I want to have one more machine, that means if I run the Kafka server in different machine, right? So it will go to same Zookeeper, right? That means we will have 2 Kafka servers.
Yeah.
So in that case, the message will be replicated between these 2 servers.
I didn't get. I mean, 2 Kafka servers you are maintaining.
Yeah, I want to run 2 Kafka servers so that it will go to subscribe to Zookeeper. And whenever the message I send to right, whenever the producer send a message, that message will be saved on one server or 2 servers.
2 servers, how you will connect here?
But
Here you are
Kafka
having
is distributed, right? They are saying Kafka is
distributed. Their Kafka cluster will you need to implement.
Okay.
So Kafka cluster come into the picture. That message will going to be published all the topics and all the slave it's going to be published. So that's where your offsets come into the picture. Kafka offset come into the picture. That's not the server you suppose not to consider, instance.
Okay. Okay.
Yeah.
Thank you.
What is the use of that Kafka group in the code?
High availability. For example, I'm getting the, let us say, Amazon Big Billion Day, millions of customers hitting. With a single Kafka instance, I'm not sure how many messages it is going to be managed. So then if I maintain the multiple message brokers, so Kafka cluster will going to be create some topic, same topics will going to be replicated. It's a like a, I can say load balancing.
How we can check high availability on AWS?
High availability on
AWS.
AWS of Kafka or AWS server itself?
AWS Kafka.
AWS Kafka. So you are having the retention service, right? So you are having the R32 service manager. You need to activate that one. So then it will going to be give all the information, high availability. So the node instances, everything you need to create. So that's you will not involve. Generally, SRE team will going to be create that one. So the developer level, you need to just publish the message, all those things. There is a R32 high availability services we are having. With that, you can able to communicate. Sorry, R32 for the Azure. AWS, you are having some other service. Service, yeah, R32 only. With that, you can able to configure. That's it. Okay, so the same link there, so you will get a notification, all those things. And if you need this code, you can just connect with the Ashok IT team. So I'm going to be sharing this code with them, so you can able to get that GitHub link. Thank you. Catch you on next Saturday.